Hey guys, this is my lab demo for your first lab on intermolecular forces. So you're going to need a few things from your kit. You're going to need your digital scale. Go ahead and pull this out and put the box aside. You're going to need the acetone nail polish remover and put this aside. You're going to need a little glass of distilled water. I just used one of the cups from the lab kit. You're going to need one of your little disposable pipettes, and you're going to need 3 pennies, which I did not include in the kit, so you'll have to find 3 pennies. Try to find ones that are relatively clean, and we're going to use them all tail side up, or heads up, whatever I said in the lab protocol. I think I said heads up, so I'll flip them. And you need the little beaker. It's the 50 ml beaker from your kit, or you can use the little plastic cup that is in the same bag with the Play-Doh, like a little plastic condiment cup. The important thing is that you use plastic in this lab. I made the mistake of, when I was demoing this myself, of using the little weigh boat that came with the thing, because I thought it was metal because it looks metal, but it's actually plastic with some kind of polish, that metallic polish, and the acetone ate that polish right off, so don't use this guy. Alright, so the lab is really divided into 2 parts, and you're going to be exploring the intermolecular forces of 2 substances, water and acetone, and we're going to be looking at surface tension using the pennies, and we're going to be looking at evaporation and doing some enthalpy calculations using the scale and the beaker. So that's part 2. So the first part is basically you're just going to be creating droplets on these pennies. And the reason you have 3 of them is because in science we never do an experiment just once. We don't do just one trial because you never know if the results are reliable if you don't repeat it. So you're gonna be doing your experiment essentially 3 different times. You're running 3 different trials on 3 different pennies. And so for the water, you're just going to get some in the dropper, and you're just going to drop it on the penny, and you're going to count how many drops it takes before the water spills over the side of the penny. And notice I'm holding the dropper up a little bit from the penny. I don't want to touch it to the penny, because when I do that, the drop doesn't have an opportunity to form all the way, so your drops won't be the same size. So you want to hold it above and let it drop from the dropper. You know, kind of move the pipette around, make sure that your drops are forming sort of symmetrically, that your drop on the penny is centered, or otherwise it will fall off. So you'll just keep adding drops. You're going to be counting these and count how many drops fit. I'm still going. All right, and while you're doing this, you also want to observe. I'm on the floor here because it's so that I can fit in my camera, but actually it's a great place for me to be able to get a side view of the shape of this drop, because you're also going to need to draw a picture of it. And so keep going. I still am on the penny here. Still on the penny. It's like hanging over the sides, but it hasn't spilled yet. I think I have 1 drop left in here. Oh, and then it spilled over the side. Okay, so I would count that as the last drop, and I'd record that, the number of drops it took for it to spill. And you'll do that 3 times, and you'll record trial 1, trial 2, trial 3, and then you'll calculate the average number of drops that the penny of water the penny could hold. And you're going to do the same thing with the acetone. So acetone is a slightly hazardous substance. Do not drink this. Don't get it in your eyes. It is nail polish remover. You get it on your hands all the time if you're removing nail polish. So it's okay. It'll evaporate pretty quickly from your skin, but it's very flammable. Don't get it near heat or flame. I actually possibly should not have put it in a mail box to ship to you if you got it in the mail. That's what you need to know about acetone. It is safe to pour down the sink, though, when you're done, and to wipe up. So you'll need a paper towel to wipe up this wet mess on your countertop. You'll dry off these pennies, and you'll do 3 trials for the acetone. Same thing. Use the dropper, drop it on. If I forgot to put a dropper, because I'm kind of thinking there might be a couple people who don't have droppers, or you might have used them all last semester. If you don't have one of these, you can use an eyedropper. You can even use a straw. You can take a straw and put it in water and then put your finger over the end and it'll lift up water, and then you can, it'll be hard to drop though actually that way. You could pinch the straw and maybe drop it like that. I don't know. You have to play around with it. But just find a way to add drops one at a time and be able to count them. As long as you're using the same device for both substances so that the drops are the same size and you're counting the drops the same, you're good. Eyedropper, like a medicine dropper, is probably the closest equivalent to this though. So that's part one. Part two is we're going to be looking at the difference in evaporation of these two things. So the stronger the attractive forces, the tighter they're going to hold on to each other in the liquid phase, and they're not going to want to leave and go into the gas phase. So we'll get to see this sort of real time by looking at the change in mass over time as something evaporates. So although we think of evaporation happening at a boiling point of a liquid, evaporation happens all the time. Individual molecules evaporate all the time. At the boiling point, all the molecules are ready to evaporate and go into, all the heat goes into evaporating them. But as you know, if you pour water in a cup and you leave it out, it will get smaller and smaller because it will evaporate even at room temperature. So what you're going to do here is you're going to turn on your scale, and you're going to make sure that it's at 0. I can't really lift it up. And then you're going to weigh your empty beaker. If it's not at 0, when you turn it on, you hit the tare button, and it will zero out. And then you put on your empty beaker, record the mass of that, and then you're going to add, we'll start with the water, you're going to add about a gram of water. So I cannot see. It says about 6 grams. So there, now it says 7.1 something grams, okay? So I've added about a gram of water. I'm going to record that mass, and I'm going to set this aside. I'm going to set a timer on my phone for 2 minutes. Timer for 2 minutes. And in 2 minutes, I'm going to weigh this again. If my scale turns off in that time, which it probably will, I'm going to turn it back on. You just always want to make sure the scale is at 0 before you put this on the scale. So you're going to weigh the water every 2 minutes, and you should see the weight slowly shrinking. You'll do this for 20 minutes, every 2 minutes for 20 minutes. Then you'll dump this out, wash it, dry it, and do the same thing with the acetone. The differences with the acetone, you're going to weigh it every 1 minute, okay? And you'll record that in your data table. And then as part of your analysis, you're going to need to graph that data. I want to see your graphing skills. And I'm okay with you doing it either by hand or on a computer program. If you need help, just let me know. And you'll also be calculating how much heat went into vaporize. You'll have to calculate how much of your water and acetone actually evaporated, and you'll have to calculate the amount of heat that was absorbed by the water that evaporated and the acetone that evaporated. So really just a lab, simple activity, but you will be applying a lot of your knowledge from chapter 10 in the analysis portion. So ideally you'll print out the lab and you'll handwrite in your data tables and your calculations. I do want to see your work with your calculations. And then you'll just take pictures with your phone, or scan it is even better because then it uploads as a single file instead of multiple files. You also will need to upload a picture of your graph. So again, you could either print that out, take a picture, or you could take a picture of your computer screen, or you could save it as a file and upload those files as what you're turning in for the lab. All right, and then don't forget to, of course, clean everything up. I'm not doing a very good job of demonstrating the cleanup part, but clean everything up, put it away. You will need the acetone for another lab, so don't toss it or use it all for your nails. Return it to your lab kit for later. And that's the lab. Bye now.